Thank you so much for joining us today. My name is Jessica Dean, and I'm a Principal Developer Advocate for AWS. I'm super excited for today's session because we're going to be focusing on container fundamentals with Amazon ECS. Specifically, this session will cover everything a Kubernetes expert needs to know. Now, sadly, we only have 25 minutes together today, but we will cover as much ground as we can. Here's a quick agenda of what you can expect from today's session. We will start with a review of how Kubernetes architecture differs from Amazon ECS's architecture. We will then map some high-level application concepts like the cluster, networking, storage, and deployment. We will end with a short demo of something new and exciting just for all you Kubernetes experts. And finally, we will wrap up with a brief recap. Diving right in, both Kubernetes and Amazon ECS are container orchestrators. But what exactly does container orchestration mean? The Cloud Native Cloud Foundation, or CNCF for short, has a very specific definition. Container orchestration refers to managing and automating the lifecycle of containerized applications in dynamic environments. Orchestration is a metaphor. The orchestration tool conducts containers like a music conductor, ensuring every container or musician does what it should. Level setting with a clear definition of what specific features make up a container orchestrator is important for us to keep in mind as we look at the similarities and differences between Kubernetes and Amazon ECS. It's also important to remember why container orchestration came to be. Specifically, what problem does it address? I'm so glad you asked. The short answer is managing distributed systems at scale is hard, and we need solutions to simplify and reduce that complexity. The longer answer, again, comes from the CNCF. Managing microservices, security, and network communications at scale, and distributed systems in general, is hard, if not impossible, to manage manually. Container orchestration allows users to automate all these management tasks. I just love this definition, partly because it reminds us that the goal of container orchestration is not just to simplify the management of microservices, but it also covers important topics like security and network communications. At the end of the day, a container orchestrator will allow users to automate these important management tasks. With container orchestration clearly defined, as well as a greater understanding of what problem it addresses, we can now look at the architecture of both Kubernetes and Amazon ECS, our two stars today in this container orchestration session. As a Kubernetes expert, this landscape overview probably looks all too familiar. As a user, whether that's dev or ops or anywhere in between, you will define your application workload in some way. This may be in a Kubernetes manifest file, or maybe through a tool like Helm or Kustomize. However you define your application workload, that definition gets sent to the Kubernetes API endpoint, which in turn sends it to the Kubernetes control plane. The control plane is made up of several components. You have your etcd, your scheduler, your controller manager, your cloud controller, etc. And from there, the control plane and scheduler will communicate with your agent pool and will schedule pods across the nodes in your cluster in accordance to what it is that you defined. Let's look at the same scenario with Amazon ECS. You may notice Amazon ECS's architecture looks similar, but there are some notable differences. As a user, you will still need to define your application workload. And again, this can be through AWS CloudFormation, AWS CDK, or Cloud Development Kit, which will generate CloudFormation files for you, AWS Proton, or even Terraform. From there, your definition will get sent directly to Amazon ECS, which is completely managed. There aren't any exposed components you as a user see or need to worry about. Amazon ECS will then launch, monitor, and scale the defined application across flexible compute options with automatic integrations to other supporting AWS services that your application needs. Now, with Amazon ECS, there is this concept called launch types. You have Amazon EC2 and AWS Fargate. The EC2 option allows you to configure and deploy Amazon EC2 instances in your ECS cluster to run your containers, whereas AWS Fargate is what we call a serverless container option. With Fargate, you don't need to manage your servers, handle capacity planning, or isolate container workloads for security. Fargate handles the infrastructure management aspects of your workload for you. You can schedule the placement of your containers across your cluster based on your resource needs, isolation policies, and availability requirements. Now that we understand the architectural similarities and differences between both Kubernetes and Amazon ECS, let's look at the application level mapping. From a high level, the concept of both Kubernetes and Amazon ECS as container orchestrators are very similar. In Kubernetes, you know your Kubernetes cluster has your control plane, as we just discussed, and within the cluster, you'll have a variety of namespaces. Within each namespace, you'll find your expected Kubernetes objects like deployment and service, among others. Each deployment will reference a pod, which can have one or more containers. Amazon ECS is similar, but there are notable differences. You'll notice in this diagram, instead of a namespace to hold your deployment and service, it's your ECS cluster. That acts as the same kind of logical boundary. Within the cluster, you'll have your ECS service, which will hold your ECS tasks, and your tasks will hold your containers. Taking a closer look, in Kubernetes, your deployment and service objects handle your pods and ultimately your containers. In Amazon ECS, your ECS service handles your tasks, which in turn is where your containers live. Let's take an even deeper look. As you've seen in the previous slides, Kubernetes pods are similar to ECS tasks. In Kubernetes, the pod is the smallest execution unit, whereas in ECS, the task is the smallest execution unit. In Kubernetes, the pod has one or more containers that share pod resources. Similarly, in ECS, the task has one or more containers that share task resources. In Kubernetes, each pod needs an IP address, whereas in ECS, a task is not required to have an IP. Now, with that said, when it comes to networking, we recommend you use AWS VPC mode for your networking configuration, and AWS VPC mode does give each task an IP address. Finally, in Kubernetes, pods are created as part of the deployment object. In ECS, tasks are created from what's called a task definition, and this is an independent object outside of your cluster. Now that we mentioned networking and IP addresses, let's take a closer look at pod networking versus task networking. When it comes to pod networking in Kubernetes, there are different container networking interface options, otherwise known as CNI options. The best option depends on the needs of your applications. For more information on CNI options, you'll want to check out the CNCF yellow pages. In ECS, task networking feels a bit more native, especially if you're already familiar with AWS Cloud. ECS task networking includes three basic options. You have your host networking mode. This means the task uses the host network, which bypasses Docker's built-in virtual network. Dynamic port mappings cannot be used in this network mode. You also have your bridge networking mode, and this can be static or dynamic port mapping depending on your application's needs. This mode means that the task uses Docker's built-in virtual network on Linux, which runs inside each Amazon EC2 instance that hosts your task. If you're using EC2 and you didn't specify a network mode in the task definition, bridge is going to be the default network mode. And finally, you have AWS VPC. AWS VPC is one ENI or Elastic Network Interface per task. If you're using AWS Fargate, only AWS VPC is supported. Let's briefly also discuss service networking. We know that a Kubernetes service is a mechanism to expose applications both internally and externally. You can create different types of services in Kubernetes. You have your cluster IP, your node port, your load balancer, external name, and headless. In ECS, the different service networking types are external to your cluster. The options include ELB, or Elastic Load Balancing, and in the case of ECS, ELB supports two types of load balancers: Application Load Balancers, or ALBs, or Network Load Balancers, or NLBs. Simply put, ALBs are used to route layer 7 traffic, HTTP, HTTPS, whereas NLBs are used to route layer 4 traffic, or TCP traffic. You also have service discovery. This uses AWS Cloud Map API actions to manage HTTP and DNS namespaces for your ECS services. And finally, you have Service Connect. This method of providing service-to-service communication was newly announced in November of 2022. This enables easy, communication between your ECS microservices and across your Amazon Virtual Private Clouds, or VPCs. It does this by leveraging AWS Cloud Map namespaces and logical service names, which in turn allows you to seamlessly distribute traffic between your ECS tasks without having to deploy, configure, and/or maintain load balancers. Now, what about storage options when it comes to Kubernetes? Specifically, Elastic Kubernetes Service, or EKS, and Amazon ECS. In EKS, both Elastic Block Storage, or EBS, and Elastic File Storage, or EFS, are supported. If you'd like to use either of these options, you will need Container Storage Interface drivers, otherwise known as CSI drivers. If you'd like to use persistent volumes with EKS, you can, since that's a native concept with Kubernetes, along with stateful sets. Now in ECS, you can use EFS, Elastic File Storage, with both EC2 and Fargate launch types. If you prefer EBS, or Elastic Block Storage, it is supported with EC2, but you as the user must mount volumes to the host and manage them. And as of right now, there is no stateful set support on ECS yet. However, I'm happy to report it is on the roadmap. Moving on, let's briefly talk about the Kubernetes deployment concept as it maps to the ECS service. In Kubernetes, your deployment object will define your replica count. Kubernetes will then maintain this replica count and will automatically replace any unhealthy pods. In Kubernetes, you can also scale up or down by simply changing this replica count in your definition. You can also adjust the rolling deployment settings using max unavailable or max surge settings. In ECS, again, there are similar concepts. Your deployment is just part of your ECS service. For service type replica, ECS will maintain what is known as the desired count, and ECS will replace any unhealthy tasks. Basically, where Kubernetes uses the term replica count, ECS uses the term desired count. Just like you can scale up or down by changing the replica count in Kubernetes, you can scale up or down by changing the desired count in ECS. There are also rolling deployment settings in ECS. There's just different terms to define them. Instead of max unavailable and max surge, ECS uses minimum healthy percent and maximum percent. Now, there are some Kubernetes constructs that don't directly map over to ECS. As a Kubernetes expert, you are likely very familiar with custom resource definitions, or CRDs. This concept does not exist in ECS. Instead, ECS uses CloudFormation as a higher-level resource deployment manager, and it supports custom resource definitions. You can use your own custom resource registry, and there is support for third parties in the registry. Now, we have discussed stateful sets already when we discussed storage options available in Amazon ECS, and again, I want to reiterate, this is on the roadmap. Now, while there isn't a direct equivalent for Helm charts in ECS, if you're more of a developer, you may be interested in AWS Cloud Development Kit, also known as CDK, which is an open source software development framework that can be used to model and provision your cloud application resources. CDK is similar to Helm conceptually, but instead of a chart, you have a construct. CDK also supports your favorite programming language in lieu of Go templating. Finally, up until now, there hasn't been a kubectl or kubectl equivalent CLI tool. Today's demo features a very, very early alpha preview of the tool the Amazon ECS DA team has been working on. Let's move into the demo. All right, I'm here in Visual Studio Code, and I'm so excited to demo ECS Ctl or ECS Control. Pronunciation preference is entirely up to you. Again, this is a tool that is actively in development. This is a preview, this is a prototype. This is sadly not available for download just yet, but we do want to gauge interest and see if this is a tool you feel would be useful for your workflow, your day-to-day operations, and especially if you're coming from Kubernetes and you want something that feels a little bit more native. Now, you can see that I have some commands up here on the top of my screen in Visual Studio Code, and we're going to go through each command, and then on the bottom part of my screen, you can see I have my terminal. The first command we're going to type is ECS Control, just to see what happens. And right off the bat, I get a list of commands I can use. Notice how native this feels already if you're used to kubectl or kubectl or K or however you want to pronounce it. For me, when I use the Kubernetes binary, I do like to create an alias. We can do the same thing with ECS Control. I'll clear my terminal session, copy and paste the command to create an alias, and now if I type the letter E, I get the same usable commands back. Excellent. Let's start off with doing registry commands. These are commands you can use if you wanted to log in to Elastic Container Registry. And for example, if you wanted to build a container image, push a container image, and pull a container image. Now, just a transparent disclaimer, I do have some environment variables I exported prior to this demo just to help the demo move a little faster. We have environment variables cached for my AWS account ID. We also have environment variables cached for some networking parameters, things like our security groups, our VPC IDs, our subnets, etc. I'll copy and paste this login command, which should be pretty self-explanatory. Now, there are shorthand for the flags you can use if you like. For example, instead of --region, you could do -r. Instead of --ID, you could do -I. But for the purpose of today, we want to make sure we have the full words spelled out so it's very clear what we're doing. In this case, we're logging into my AWS account to gain access to any container registries in the US East 2 region. And you can see I was able to log into that registry accordingly. Now, let's clear the screen and we're going to build an image. And here's a little teaser. You can see that there's something called Croc Hunter. By chance, if you're familiar with any demos I have done, even 5 or 6 years ago, even back with the announcement of Helm 3, Croc Hunter may be familiar. If not, you're hopefully in for a treat. I find it pretty fun. It's an app designed by Lockie Evanson, who's part of the Deus team originally, who helped bring Helm as you know it to life. Anyway, all of that aside, Croc Hunter is an application he designed where you can live out your dreams hunting crocodiles. And we made a special ECS version that we're going to deploy with this new tool. Now, in order to build an image, we have to be in a directory that has our Docker file and our Docker context. To do that, I'm going to go ahead and change directories over to my Croc Hunter directory. I'm going to clear the screen again, and I'll just copy and paste this command and let it build. Again, this should be very self-explanatory. We're using the ECS control tool to build a container image in the region US East 2. That's going to tag the image appropriately with the proper region and the proper syntax for our Elastic Container Registry. We also have the account ID for my AWS account, as well as the name of this repository. Excellent. You can see that it's successfully built and successfully tagged that image. Now we're going to push the image. But before we do, I just want to switch over to my browser here real quick. And you can see that I already have a private repository called Croc Hunter. But when I drill down into it, it's currently empty. There isn't any kind of magic or smoke and mirrors here. It's completely empty, and we're going to push our newly built image into it. Let's flip back over to VS Code, and let's just quickly run Docker images. And you'll see I only have the one image I just built. Let's clear the screen, and we'll copy and paste our command to push the image. Again, this command is pretty self-explanatory. We're using ECS control push. We specify the region, the ID, and the name of the image. And you can see that it was pushed. Let's go ahead and flip back over to our browser here. And we'll go ahead and refresh. And great, I can see that the image has been pushed and we're using the latest tag. I'm going to switch back to my terminal and let's do a quick Docker RMI cleanup command to remove all images on my dev machine. Now I'm going to pull that newly pushed image from our Elastic Container Registry. I'm again going to copy and paste the pull command, and you'll notice, again, this command is very self-explanatory. You enter the region, the ID, and the name, and it pulls the corresponding image. Great. All right, let's go ahead and clear the screen. I'll run Docker images again, and there is our newly pulled image. Notice how snappy and quick these commands run. That's probably one of my favorite features. Now that we've played with some registry commands, let's switch gears and run some cluster and application commands. This time, let's go ahead and use the alias we created. We're going to run eclusterlist, and you'll notice I currently don't have any clusters. Just to triple check, I'll flip back over to my browser and check the AWS console. And yep, there aren't any clusters. Perfect, that's what we love to see. Now let's create a cluster. And again, I do have environment variables already saved, already cached, and that includes the cluster name I want to use. I'm going to copy and paste the ECS control cluster create command, and just like that, you can see a cluster has been created with the cluster name JD ECS Cuddle test. Let's go ahead and run a describe command real quick. Great, we get back expected information like the cluster name, the ARN, and even the status. I can switch back over to my browser again real quick just to visually confirm, And sure enough, I see my newly created cluster in the AWS console. Now, if I drill down into this even further, I get the same information that I had in my terminal. Great. Let's go ahead and jump back over to the terminal and now get our application deployed. This time, we're ready to actually live out our dreams hunting crocodiles. Now, to do that, I'm going to create a task definition by copying and pasting this command. I'll just pass in some details here, like the ARN I want to use, as well as how much CPU and memory the app needs and the image. We also need to make sure that we specify where the application is listening, which happens to be port 8080. So I'm mapping the container port and host port to 8080. And I'm going to run this using the Fargate launch type. Again, that's the more serverless method of running your containers in ECS as opposed to ECS with EC2. Either one's fine. I'm just using Fargate today. And great, we have created the definition successfully. Now, just to see what that task definition looks like, we can again run a definition list command. Notice that we get the ARN back, as well as other important details like the revision number. We can also run a describe command and get back other helpful information. All right, I'm going to clear the screen and switch back to our browser. I'm going to click on the task definitions real quick, and I can see I have my task definition and the revision number is 5. All of this is looking great. All right, we can also switch while we're here to our cluster real quick and verify, yep, we don't have any services or tasks running. Let's fix that. I'm going to jump back into my terminal and we're going to create a service. To do that, we're just going to use the ECS service create command with some basic flags. We need to provide the cluster name, the container name, the launch type, the container port. Again, our application listens on port 8080, but this time we want to make sure that it's publicly accessible on the web using our application load balancer. So we're going to attach that to port 80. If you're used to Docker, basically we're just routing the internal port to the external port. We're going to enable the public IP address. The scheduling strategy in this case for Fargate is going to be replica. That's the only one allowed. If you were using EC2, you could also do daemon if you wanted to. And then you also have service names. Now, notice these security group, subnet, target group, these are all set as environment variables. Again, for the sake of time, I've already exported that. I'm just attaching it to existing networks, existing security groups. I'm going to copy and paste this command, and notice how fast that service was created. Now, while it's spinning up the container and going and fetching that container image, let's run a quick describe command using ECS service describe. Notice how any type of command, whether it's ECS definition, service, cluster, you can use the same subcommands like describe, list, create, etc. And I can see we have the service desired count. We can see the service is active. We can see it's currently pending. We're still waiting for that to get up and running. I can see even the service platform is latest. I see a lot of really helpful information. I'm just going to clear the screen. And again, I'll jump back over to my browser. And awesome, I can see that the service is running. I have 1 out of 1 tasks. I have my replica. It's active. There's my service right here. This is fantastic. Again, all of this was deployed from our tool. Now, I'm going to switch back to my terminal, and I'm going to grab this command right here to get the FQDN, or the fully qualified domain name, and then I can echo that out, and we can actually open our app so we can hunt some crocodiles. Awesome. All right. Yep, you can see that the host name matches Amazon ECS. It's powered by Amazon ECS. And if I click start, I even get to use the ECS rocket ship, which is honestly pretty fun. Now, check this out. I even have lasers, and each crocodile I hit is 5 points. Oh gosh, Okay, there's quite a bit of crocodiles here. All right, I'm gonna switch back over to my terminal, and it's time to run some quick cleanup commands. We've already done a describe command on the service. Let's go ahead and see what the list command would look like. I'll copy and paste that in, and again, I get the ARN back. So we know that that service exists, and we just use the app. We're gonna delete the service. I'll copy and paste in the delete command, and it's deleted. To confirm, we'll go back up 1 command and run list again, and I no longer get anything returned to me. I can switch back over to my browser just to do a quick sanity check, switch to services, and again, you can see that no service exists. That service is gone. Jumping back over to our terminal, let's go ahead and clear, and we'll update the revision number to 5. We'll run the definition delete command. Great. We can run a quick e-definition list and we'll see, perfect, there aren't any return. Now let's go ahead and just delete our cluster, and that'll be the final part of our cleanup. We'll clear the screen, paste in our cluster delete command, and perfect, I can see cluster JD ECS cuddle test was deleted successfully. Jumping back over to the AWS console real quick in our browser, and I see I no longer have any clusters, or if I also check task definitions, those have been deleted as well. Phew, we have learned a lot today, and we've reviewed key architecture similarities and differences between Kubernetes and ECS, and we've mapped some terminology to better understand ECS as a container orchestrator. One big difference between ECS and Kubernetes is ECS sees itself as part of the AWS ecosystem and not a replacement for other AWS services. This is why some concepts that are internalized to Kubernetes are externalized in ECS. This is an important philosophical distinction for those of you coming from Kubernetes over to ECS. Again, if you liked what you saw in the demo and you would like to provide feedback or help shape the product, please reach out to Scott Colton or myself. We are working with the product managers to see if it makes sense to integrate that tool more fully with the core ECS tools. And again, if you like what you see, we also encourage feedback on either Twitter or Blue Sky to help the PMs prioritize. Thank you so much for hanging out with me today. I have had a blast.